Hello everyone. In this lecture video, we will understand some of the features of CloudSim. First is data center simulation. Second is virtualization support. Next comes the dynamic virtual machine allocation. Then you have custom resource policies. Then next is flexible components. And the last is pause and resume. So CloudSim, it is a Java-based cloud simulation toolkit developed by the University of Melbourne for research and educational purposes. It helps the users model, then simulate and test cloud computing environments without using the real cloud infrastructure. So the researchers and students, these use CloudSim to study how data centers, then virtual machines, applications, and cloud resources work together. So it supports features like virtual machines, then resource management, scheduling policies, and energy aware computing. So CloudSim is widely used to evaluate the performance, cost, and efficiency of the cloud system before real deployment, and it is used for cloud computing research, academic projects, and testing new cloud technologies in a safe and flexible environment. Now, the first feature is the data center simulation. So, data center simulation is one of the important features of the cloud simulation or the CloudSim. It allows users to create and test virtual cloud data centers in a simulated environment without using real hardware. So, the researchers can model multiple data centers, servers, network connections, storage system, and virtual machines. And this helps in studying cloud performance, resource allocation, workload management, and communication between the different locations. Now, here in the figure, you can see how CloudSim can simulate multiple cloud data centers located in different countries such as India, USA, and UK. Now, each country contains a data center, so which is represented by these servers and buildings. And these data centers are connected through network links which represent communication between the cloud system across the world. Now here at the center you can see there is network connections that shows that the CloudSim can simulate internet communication, data transfer, and connectivity between different locations. And this will help the researchers study how cloud systems behave when users access services from different regions. Now here you can see a student, or you can say a researcher, he is using a CloudSim on a computer in order to create and monitor the simulation. And here on the right side you can see here it is displaying a simulation view where all the three data centers showing running successfully. So this indicates that the CloudSim can monitor the performance and the status of multiple data centers at the same time. And this feature, it is very useful for testing cloud applications, analyzing network delays, studying resource sharing, and improving system performance before real-time deployment. So the researchers can safely test different cloud configurations without using actual hardware, which reduces the cost and saves time while improving the efficiency and reliability in cloud computing experiments. Second is the virtualization support, which is another important feature of the CloudSim, which allows users to create and manage multiple virtual machines on a single physical server. So a virtual machine, it behaves like an independent computer with its own operating system and applications, and the CloudSim helps researchers how virtual machines share CPU, then memory storage and bandwidth resources efficiently. Here it supports virtual machine scheduling, also it supports migration and allocation policies in the cloud environment. Now suppose, for example, you have a single physical server, okay, which can be it is divided into multiple virtual machines using the virtualization technology. Now here on the left side there is one powerful physical server. Instead of using the entire server for only one user, Virtualization allows the server resources to be shared among multiple users. So in the center, the virtualization layer divides the physical server into 5 different virtual machines, that is VM1, VM2, VM3, 4 and 5. Now each virtual machine works like an independent computer with its own task, operating system and applications. Now different users are connected to different virtual machines, which means multiple users can work simultaneously on the same physical hardware without affecting each other. So here you can see different users are assigned to separate virtual machines for different tasks. Now this demonstrates how cloud systems can support many users while efficiently managing the CPU, memory storage and bandwidth resources. Now here this figure, it also highlights that virtualization improves the resource utilization, reduces the hardware cost and increases the system efficiency. And in CloudSim, researchers can simulate and study VM creation, that is the virtual machine creation, then allocation, scheduling and performance without using the real cloud infrastructure, and this will help in testing cloud computing environments, workload management and resource sharing strategies in a flexible and cost-effective manner. Next is the dynamic virtual machine allocation, which is another feature of CloudSim that allows virtual machines to be created, added or removed automatically during the simulation based on workload requirements. So here it helps the cloud systems to adjust resources according to the user's demand. And during the high traffic or the peak traffic, more virtual machines can be added in order to improve and handle many users. And when traffic becomes low, that is the off-peak traffic, extra virtual machines can be removed. Okay, you can see here cross marks, which can be removed to save the resources and the energy. Now, here this figure, it explains the dynamic virtual machine allocation, which is one of the feature of the CloudSim. Here it shows how virtual machines can be automatically added or removed, and during simulation depending on the workload and the user traffic. Now here on the left side of the image, you can see users access an e-commerce app or application. When many users use the application at the same time, the system will detect what? It will detect high traffic and increases the number of what? Virtual machines. Now this process is called as scaling up. So additional virtual machines are created automatically in order to handle more requests, improve the performance and provide better service to users. Now here you can see peak traffic conditions where more virtual machines are being added in order to support the growing workload, and as a result the application can handle more users efficiently without slowing down. And this result section highlights the benefits such as better performance, efficient source utilization and smooth service. And this lower section, it explains scaling down, which helps scaling down during the off-peak traffic. That is when few users are active, extra virtual machines are removed automatically in order to avoid wasting the resources, and this will help in saving the energy, reducing the operational cost and improving the efficiency. Then next comes the custom resource policies. So here you can see how the cloud resources such as the CPU, okay, then RAM, storage, bandwidth, these can be allocated according to a user defined rules and priorities. On the left hand side, you can see users are divided into two groups, that is premium users and the normal users. Okay, so premium users are given higher priority while normal users receive standard priority. In the center, you have the customer resource policy section that shows which shows that the researchers or the cloud administrators can define allocation rules, and in this example the policy gives more resources to premium users than the normal users. Now the resource allocation section illustrates how the cloud server distributes the CPU power, memory storage, and bandwidth, and the premium users receive larger portions of the resources. Okay, while normal users receive the remaining resources. Here you can see the green color because they are receiving the higher resource allocation. Okay, now the right side of this figure, it displays the result of applying the uh, policy. Premium users get more resources, that is the higher priority, and they get faster service and better performance because of higher resource allocation, whereas the normal users still receive services but with the lower priority. So this feature is important because the different cloud applications require different scheduling and allocation strategies. CloudSim allows researchers to test these policies before implementing them in real cloud systems, and it helps studying fairness, quality of service, load balancing, performance improvement, then efficient resource management in cloud computing environments. So here what you can say, the custom resource policies, here users can define how resources are allocated. Next comes the flexible components. So flexible components, these are the important features which allows users to easily add, remove, or modify cloud components during the simulation. The researchers can change servers, virtual machines, users applications, or tasks according to testing the requirements. And this flexibility helps in creating different cloud scenarios and studying system behavior under changing conditions. For example, you will be having n number of users who can suddenly increase to test how the cloud system handles heavy workload and maintains performance. And users can also add more servers then or resources to balance the load. So this feature is useful for scalability, testing performance, evaluation, resource management, and analyzing real world cloud computing situations in flexible and cost effective environment. Now here in this figure, it shows that the users can easily add or remove users, task and application during simulation according to system requirements. And on the left side of the figure, different cloud components you have servers, users, okay, and you have task applications which are displayed with add and remove signs or options. This indicates that the CloudSim provides flexibility to modify the cloud environment at any time. That is, you can add or remove the servers, users, and the task applications. Now here in the center, you have, like in the first stage, the system is running under normal load with small number of users and the servers. Okay, here. Now what happens in the second stage? In the second stage, the number of users suddenly increases, creating a heavy workload and it creates heavy workload on the system. And in the third stage, the system adapts by adding more servers and resources in order to handle the increased demand efficiently. This demonstrates how CloudSim can simulate real-world cloud simulations where workloads change dynamically. And on the right side of the figure highlights actions users can perform, that is such as adding or removing the servers, users, and the task and changing the configuration. Okay, here the servers can be added or removed, then users, then task, and we can change the configurations. So this result section at the bottom explains here. Okay, so here it explains the benefits of flexibility, including easy testing of the different scenarios, analyzing system performance, improving scalability and reliability, and making better decisions. So overall, here this figure shows how CloudSim helps researchers study cloud behavior under changing conditions in a flexible, efficient, and cost-effective simulation environment. Then comes the pause and resume, that is the last feature. So here, this feature of the CloudSim allows simulations to be stopped and restarted at any time and at any state of execution. So the researchers can pause the simulation to analyze intermediate results, check system performance, observe resource usage, and or the debug errors. Now after analyzing, the simulation can continue from the same point and without restarting from the beginning. So this feature saves time and helps in detailed study of cloud system behavior. For example, a user can pause the simulation during the task execution to examine how virtual machines and resources are working, and it is very useful and helpful for performance analysis, testing different strategies, debugging problems, and improving cloud resource management efficiently. So here, this feature allows simulation process to be temporarily stopped and restarted from the same point whenever needed. Okay, and here in the first stage you can see the simulation runs normally through the different phases, okay, such as initialization, then task execution, processing, and finishing. During the execution, the users can pause the simulation at any intermediate stage, and this helps researchers analyze current results, resource utilization, then virtual performance and system behavior without ending the complete simulation. Then you have the middle section of the figure which shows the pause operation, where the simulation stops temporarily, and at this point users can add they can study graphs, logs, and performance statistics, and this is very useful for debugging errors, checking bottlenecks, and understanding how resources are being allocated in the cloud environment. After analysis, the simulation can be resumed. Here the simulation can be resumed from the exact point where it was paused, and the lower section here of the figure shows that the remaining stages continue normally until completion, and this avoids the restarting the entire simulation again, which saves time and computational effort. Okay, so the overall pause and resume feature gives the researchers better control over simulations, and it helps in testing cloud systems efficiently, comparing the results at different stage, and improving the accuracy of the cloud computing experiments and the performance analysis. So this is about the features of the CloudSim. Thank you.